Hi, my name is Samir Mohammadzadah, and this is my teammate Tyler MacDowell, and we are going to be presenting using Neo4j with Python. A quick outline of our presentation: we're going to start with an overview, touching on our hypothesis. Then we're going to talk about the power of querying with graph databases, and specifically Neo4j, which is the graph database we chose. We're going to then draw the link to Python, and then derive some business value from implementing Neo4j into your company, and then conclude with a wrap-up. So our hypothesis is utilizing Neo4j's graph database within Python allows a business to make frequent schema changes, manage massive amounts of data, perform real-time querying, and gain more valuable analytics from highly connected data.
So then when we look at the power of querying within graph databases focus specifically on the relationships between 2 points of data, and that is held at a priority. So querying is much faster than with a relational database, where it would have to perform all the different inner joins between tables, and then it actually scans through every item in each table in order to return the query result, where graph databases just connect each point using that relationship. Then looking specifically at Neo4j, we have a little bit of an example of kind of the power of Neo4j when it comes to visualizing and working with data. So we have a sample set of data of a bunch of people and different movies they watched and what they rated those movies. So this will show us all the different movies that David Farmer, a certain user, has rated. So we run that and we can see this visualization of all 299 movies that David Farmer has rated. Then we're going to go ahead and break that down. We can go ahead and see what the average rating he gave a movie is. So on average, he rated a movie a 3.65. And then running another query here, we can go ahead and return all of the different movies which he rated above average. So then we see he rated 213 different movies above that 3.65 average rating, and this is a visual representation of all of those. So then going back to our presentation, Neo4j allows us to get data into Python and have it in a very visually appealing way where we can perform queries and data analytics on it.
So here's a quick cipher syntax example of a graph model. On the right there, it uses the different components of the Neo4j syntax, and it's a bit confusing. However, if you look to the left, it's sort of an English translation, where you see that Jennifer likes graphs, Jennifer is friends with Michael, and on the last relationship there, Jennifer works for Neo4j.
So then seeing how we link Neo4j to Python, they're connected using a client library called Py2Neo. And this allows us to work with Neo4j and edit a graph schema within Python. So then here, the example on the left would be how you would create and edit a graph within Python. You can see that snippet of code is creating a node Jennifer and a node Michael, both as people, and creating the relationship is friends with. So Jennifer is friends with Michael is the result from that code. And then on the right, this kind of shows how you would go about querying a graph in Python. It also shows that you can import a currently made graph. So you don't have to create the graph in Python, but you can import the data of a graph and then run queries on it and also run other analytics that you would like to with Python.
So now, why would a company adopt Neo4j into their organization? Here are some use cases of why Neo4j would be useful. First would be fraud detection and analytics. So if there's any fraudulent activity or security concerns, Neo4j can spot that, which would be beneficial to breaches, which are very common nowadays. The next would be product recommendation engine. This is very beneficial for e-commerce sites, recommending new products to customers. So this would draw value to both the customer as well as the organization. And lastly, social network graphs. This makes inferences on who is part of a very close social network, so maybe to add a friend or to follow another person. Now, a quick wrap up. We saw that graph databases are a lot more efficient in processing and visualization, and then we draw that link with Py2Neo. And lastly, there's those various business values that are derived, which we have more that we did not mention in our appendix, as long as other information in our appendix and our handout. Thank you.
Thank you.